So this is slide 23 of the chapter 6, and your calculator has the normal distribution built into it. So your calculator has the ability to tell us that this area is 68%. And I want to show you how to do that. So go to second distribution, and I screwed that up, second distribution, and then we're looking for normal CDF, so the second option. Don't choose PDF, choose CDF, because we're doing a range of values. Enter. And then there are 4 inputs. So depending on your calculator, this particular one has me put the 4 inputs up here. Lower, upper, mu, sigma. My actual TI-84 is not a TI-84 plus, so it's a little bit more low-tech, and it shows this. But either way, you're giving your calculator 4 pieces of information. Lower value, upper value. So we're going to say 85, 115, and then we'll say mean standard deviation. So then we'll say 115. So the 2 parameters of the distribution are last in this case. So I'm going to clear out what it says there. Negative 1E99, we'll be doing that soon. But I'm going to say 85, enter, 115, enter. Mu is 100, enter. Sigma is 15, enter. And I'm expecting it to say 68% when I hit paste. And then I have to hit enter one more time, and it says 0.6827 if I round to 4 decimal places, or 68%. So that's the 68% that the empirical rule gives us. Find the probability that x is between 100 and 130. So same process again. I'm just going to be changing these 2 values. So I'll do, actually you can be lazy and do second entry, and then just go back in here and change the values. 100, second insert 0, so I don't have to retype everything. 130, and then everything else is the same. Or of course I could go back into second distribution, choose the second option, 100, 130, so those are my lower and upper bounds, and then mu and sigma, and then I paste it in there. So this gives me 0.4772, which is approximately 0.48, and we had gotten 48% last time, I think. Okay, so that's how normal CDF works on your calculator for that problem. Now, if we wanted to do what is the probability that x is lower than 70, so we had done this calculation, and you might be like, well, what's the lower end? We're going to do normal CDF something, 70, and then the 115 will remain. So we really just need a low number, a pretty low number, and I was thinking we could just use 0, because it seems like you can't have an IQ score lower than 0. But I was going to tell you that your book always uses negative 1E99, which just means a huge negative number. So if you're paranoid and you want to have the absolute best possible option, this really means negative 1 times 10 to the 99th power, which means negative 1 with a bunch of zeros behind it, 99 zeros. I'm not going to write them all out. And so let's go in and do that. Let's do second distribution, normal CDF, negative 1 And then the E is right above the comma, so I do second E. The funny thing is that there's a double E, but then when I type it, there's just one E, 99, and that's my lower bound. My upper bound is going to be 70, and then everything else stays the same. I'm expecting 2.1%. Okay, well, I got 2.3% actually, so my previous estimate was a little bit off. This is more accurate. And it looks like I got the exact same result if I did 0 as my lower bound or that really huge negative number. Still gives me the same result, so it doesn't make a huge amount of difference, but I just figured I'd explain what your book is doing there. And of course, the probability that x is greater than 70, I can just do 1 minus second answer, and that's 0.9772, or 97.7%. The left end is negative 1 E99, and the right end, if you needed a right end point, would be positive 1 E99. So this is an example of showing you that to find the area to the right of 70, you could say 70 is my lower bound, 1 E99 is my upper bound, mean and standard deviation, and that gives me the same result.